Good day. Today we can discuss the topic about one-dimensional problems in finite element analysis. For understanding purpose, I consider this problem. The problem is a two-noded truss element is shown in following figure as like this. Okay, here the element length is L. It has two nodes which are 1 and 2. The at node 1 the displacement u1 is equal to 5 mm and u2 is equal to 8 mm. So the nodal displacement or u1 is equal to 5 mm and u2 is equal to 8 mm. So from this problem they ask calculate the displacement at different points which are x equal to L by 4, x equal to L by 3 and x equal to L by 2. So how can we identify these displacement with the aid of finite element analysis? Let's see. Here the solution can be started from the formula utilization. The general formula for displacement function is u is equal to n1 into e1 plus n2 into u2. According to our problem, we are having the u1 value and the u2 value, but we are not having n1 and n2. How can we identify the n1 and the n2 value? Yes, this also have some formula, which means n1 is equal to L minus x divided by L. From this we can identify the n1 value. And then n2, how can we identify the n2? Yes, n2 can be identified through n2 is equal to x by L, which are the formula we can utilize to identify the n1 and n2. In our problem, we are having u1 value as 5 mm and u2 value as 8 mm. From this, we can easily identify the displacement functions. Let's see how can we identify the displacement function. For identifying the displacement function, first I consider the question about x equal to L by 4. What is the displacement at x equal to L by 4? Which is the first question. And the second, the x equal to L by 3 means what is the displacement, and if the third point x equal to L by 2 means what is the displacement, which are the questions we are having. So how can we solve? Let's see. Here the formula is u is equal to n1 u1 plus n2 u2. So I can substitute the n1 and the n2 value with this formula. I can get u is equal to L minus x divided by L into u1 plus x by L into u2, which is the formula I utilize to identify the things. Let's see next. Yes, I can move the formula with the u which is equal to L minus x divided by L into u1 plus x by L into u2. So now we are having u1 is equal to 5 mm and u2 is equal to 8 mm. And the first condition, which means first question is x equal to L by 4 and the u1 is equal to 5 mm and u2 is equal to 8 mm. So how can we identify the values? Yes, now I can substitute the x value in the considered formula. So u is equal to L minus L by 4 divided by L into u1 plus what is x, L by 4 divided by L into 8. I substituted the x value in the find displacement equation. Okay, from this I can solve. Okay, for L minus 4L, how can I write? Yes, 4L minus L divided by 4L. Likewise, I can simplify into u1 plus L divided by 4L into 8. After that 4L minus L, which means if I solve that, I can get 3L by 4L. What is the value of u1? Yes, according to our problem, u1 is equal to 5 mm. So that I substitute here 5 plus L divided by 4L into 8. I substitute that. So now I can cancel L, denominator, numerator, L. I can cancel. Now 3 by 4 I can write as like 0.75 into 5. And what about the second term? In the second term, 1 by 4 I can write as like 0.25 into 8. If I simplify the thing, I can get 5.75 mm, which is the displacement that is available with our node 1. After that, we can identify the other things. The other things are in our problem we are having. Yes, x equal to L by 3 and x equal to L by 2. If I substitute and calculate the same manner means I can get the other view as like for x equal to L by 3 I can get u is equal to 6 mm. If I substitute x equal to L by 2 means I can get u is equal to 6.5 mm. Likewise, we can easily calculate the one-dimensional problem with the finite element analysis. Thank you. If you are having any doubts, you may ask me through comment box.